Cool. Thank you. Good to see so many people this morning. So I'm here to talk about the Internet of Things and sort of Android Things, which is Google's platform for the Internet of Things. And so just to get a quick sort of gist of the audience, is there anyone here who works with the Internet of Things? Cool. There's a couple of people. And anyone here before who's used Android Things? I know, has it been out too long? Cool. Have we got many Android developers here? Oh, great. OK, cool. I can't make too many mistakes then. The Internet of Things is quite a vague term. Like, if you haven't come across anything before, you'd be like, what the hell does that mean? But to put it into a nutshell, if you don't have any experience with it, we can put it into sort of two categories, to say. To begin with, we have what are called smart devices. Smart devices are devices that do what they say on the tin, something smart, something clever, and something for the user, but they don't connect to the internet. They don't rely on any form of remote connection to do the task that they're doing. Maybe they're programmed to do something with smart light bulbs, or they relay back to you information with speakers, or they're just a visual aid for something. They don't use any external connection to do their job. And then on the other hand, we have what are known as connected devices. As connected devices are kind of the complete opposite of this. They do rely, or they don't rely, but they do use some form of remote connection to do their job. So maybe they connect directly to the cloud or some API and request some information to relay back to you. Or maybe they connect to the internet through a paired device, like a phone. Maybe your phone communicates with the internet, and then your phone relays that information back to the device. So it's connected in one way or the other. So this is the ways in which we can categorize Internet of Things devices. The key thing with these Internet of Things devices that we have is the user interface is not always present. So we're so used to, on our mobile devices, having this screen that we touch and we prod and we design for, when we design applications, we have a screen, and it's, that's the way we're used to working. But with the Internet of Things, this changes completely because our devices don't have to have a screen. And this is obviously, we have pros and cons to this. Like, to begin with, production costs can be reduced significantly because screens are expensive, and it's the main part of your phone that you interact with is the screen, so they can get damaged, it can crack, and also they use a lot of battery power. So removing that need allows us to reduce the costs of our product, increase the battery life, and we have those advantages. But we also have to think about how else our users can interact with those products. So it becomes more about the user experience. And another point here is that the mobile phone is quite a personal device. Like, I don't know about anyone here, but my mobile phone's just for me, and it has that one job. It's for you, a personal experience. But the Internet of Things allows us to create for so many more use cases. Like, maybe we're creating a device that's for a specific group of people. Maybe it's something for accessibility, and maybe it's something specifically for people who have hard of sight or hard of hearing. Or maybe it's something that's going to be in a car showroom or in a hospital. Or maybe we are going to create something that's for many users. And it gives us much more freedom to create something that's tailored to specific needs. So whilst our phone is, our phone is kind of like a one for all. Like our phone does everything. We can call people, text people, use numerous apps, and these apps do so much. But the Internet of Things, we can really create something that just does this singular task in this one use case, and it does it perfectly. And when it comes to the interaction with these, like I said, with our mobile phones, we're pretty, we have a screen, it's a touch screen, and we can talk to it and we can hear stuff. And that's kind of the limitations, unless we're going to start plugging in external hardware. But when it comes to the Internet of Things, we have so many possibilities to play around with and experiment with. Maybe we want to use sensors, like we want to sense light or humidity or some form of movement, for example, and maybe we just want to use that. Or maybe we want to relay information back to the user in the form of speakers. Maybe we could go down the route of things like Google Home and Alexa and introduce a microphone, and maybe we want to allow the user to talk to our device and then use a speaker to relay back to information. or maybe we don't use a speaker at all. We can mix and match combinations of different hardware components to create this experience. Some devices will have buttons. Some devices will have touch screens. Whilst I said our devices don't have to have a screen, maybe we want that screen. And this allows us to sort of create our experience that's for that use case. But if we do decide to use screens in our devices, this is just a little topic that I'd like to touch on. It's called inter-usability. So creating an experience that is familiar across the platforms. Like, it's a common thing, say if you've got a mobile app, and then you've also got a website, probably. Crossing between those two different platforms and using those services on different devices, they're usually the same. It's the same experience, and you don't have to change your behaviors or the way you think to interact with them. And that should also be true for the Internet of Things. So this company is called Nest. If you haven't heard of them, Nest is like a smart energy company, and they provide an app which allows you to change the heating and stuff in your home. And from looking at this, you can already see that the look and feel moving from the mobile app to their little Internet of Things device is pretty much exactly the same. There's a slight change of color, but yeah. So you could go from using that app to using that device, and you wouldn't have to change your way of thinking or the way that you behave with that device. And another point here to point out is that going back to that thing of designing for a specific use case and doing that singular task and doing it well and simply, is you can see that in their app, does it have a pointer? Yeah, so in their app, you can change the heating, the fans, you can schedule stuff and view history and do all these other complicated things, which makes sense for an app because your app is your one-stop place to do all this stuff. But on the other hand, this device, it doesn't have any buttons on the outside. It's just this really sleek, stunning device that goes on your wall that just does this one thing. And it does it pretty well. And this is taking the app and simplifying it down into this small device that you can use without having to overcomplicate things with the app. And when it comes to this hardware, this isn't even a smart or connected device, but just something that I wanted to point out. When we come to using components to build for the Internet of Things, because we have access to the physical world, we can use anything we want to create these devices. And this is a company called BitPlanner, and they have this thing where you have sheets of Lego on the wall, and you can use Lego bricks to sort of plan your schedule. And then what you do is you use their app to, you hold your phone up, the camera in the app to the BitPlanner, and it automatically translates that schedule into their app, and it imports it into your calendar. So whilst that itself isn't actually doing much, and the app is doing all the work, I think this just shows that you can make things fun and familiar. Like, I don't like planning meetings, and I don't necessarily enjoy meetings myself, but I love Lego, and I think there's not many people who don't enjoy playing with Lego. So this is taking something that is fun and nostalgic and changing something that necessarily isn't fun and nostalgic and merging them together to create a better experience. And this is what we can do with the Internet of Things. Maybe you want to make a project that uses Lego. And with these hardware components that we've talked about to design the interaction of our product, such as sensors and motors and stuff, we have essentially two categories, again, that these components fall into, that bridge the gap between the physical and digital world. And the first one are known as sensors. So sensors are something that allow us to take information from the physical world and sense it so that we can use it in the digital world. So maybe you want to sense light or movement. And then we can use it in our device or application and do as we please with it. And on the other side of things, we have actuators. Actuators are the complete opposite of what a sensor is. An actuator allows us to bridge the gap between the digital and the physical world. So we can, perform some form of physical action, such as, maybe a smart lock or something, or opening a door or some other physical means. So talking of these are all completely new things. Like even to me, before I started playing with the Internet of Things, I'd never touched any of these things before, and I was so used to working so closely with these screens that I do in the Android ecosystem. So the thing is with the Android ecosystem is that we have touch screens, we have touch screen watches, touch screen phones, we have Android Auto, we have Android TV, and they're all the same thing. They're all using screens, and most of them are using touch screens. But then we have Android Things, which is just this Internet of Things device, which at first glance you're like, well, how does this fit in? Like, it's quite different from the other devices. How am I going to build for it? And what the cool thing is with this is that it's running exactly the same operating system that these other devices are. So just like your phone or your watch, the Android operating system is sitting on that Android Things device. And this is great because the idea behind this is Google want to make it just as easy for us to make mobile apps, to make Android Things apps, as it is to make mobile apps. To have that simplicity in place so that we can take our existing knowledge and build for the Internet of Things. And like we were saying, Internet of Things has always been, and for me as well, this area where I've always been interested in it, but I've never felt it's that accessible. But now with the introduction of Android Things, and there's so much resource in the community to do with Android, and I can use existing knowledge, I feel a lot more confident and comfortable in experimenting. So Android Things brings us, there's a few differences with the platform. Some of them are good. So we're just going to run through some of the changes in the platform. So the key point, which I'd like to point out, is that we can use exactly the same tools and APIs, mostly, that we're currently using to build Android apps. So maybe you're using Firebase in your applications. Maybe you write code in Kotlin, or maybe you're making reactive apps with RxJava. And maybe, or I hope, you're using Android Studio. The cool thing is that you can still use these exact same tools and APIs to build Android Things apps. You don't need to change any of your behavior at all. Maybe you're not an Android developer, but because the Android community is so big, maybe you probably have friends or co-workers who work in the Android who can help build stuff for you. And because the Android Things APIs are pretty much the same, there's no more learning curve for these developers. And things I've built on Android Things tend to be, there's more work from the hardware side of things, and the actual code itself is always quite minimal, so they're usually apps that are usually quick to whack out. And maybe you don't know anyone who is an Android developer, but because these communities are so big online, it's easy to find the resources if you want to learn. There's no added learning curve if you want to get started. So the next point is that there is some new APIs that have been introduced with Android Things. And this is called the Things Support Library, named well. So this essentially gives us access to two new APIs. Not going to go too deep into these, but the first one is called the Peripheral Input-Output API. And this allows us to allows our application on our Android Things device to communicate with the sensors and actuators that we previously spoke about. And then the second is known as the User Driver API. And this essentially allows us to, in a nutshell, write drivers for hardware that might not already be supported by Android Things. And the cool thing about this is a lot of developers are open sourcing these drivers. So sometimes you won't even need to sort of write drivers using this API because half the time the driver might have already written for you. So if you're an Android developer, or you've probably seen this diagram already, but this is what the general stack for an Android application looks like for Android OS. So this green part here is sort of at our application level. So this is the classes that our code will interact with and that we have access to. And then the top layer at the top is kind of the applications that would generally come installed on our mobile devices. So whilst this is pretty standard, what it looks like for on the mobile side of things, when it comes to Android Things, there's a couple of changes. So the API isn't exactly the same. So to begin with, the applications that would come installed on stock Android devices are completely stripped away. So your Android Things device, when you install Android Things on your Raspberry Pi or whatever device you have, you won't find the phone app or the messaging app or the contacts app. And this is solely because of the lack of screen. So this wouldn't make sense. Like, how would I access my contacts or call people if I don't have a screen? So they've stripped that away. And then at an application framework level, the parts that our code can interact with, there's a couple of changes as well, and these are also related to this lack of UI. So the 2 points here that I think are the most important are, to begin with, notifications. So we no longer have access to the notifications API in Android Things. This is solely because of the lack of screen, so because our device may not have a screen, so Google has sort of stripped away that ability to use notifications. And the second is runtime permissions. If you're an Android developer, or designer, you'll probably be familiar with runtime permissions in Android that were introduced in Marshmallow. So this basically means that we have to request the permission from the user to do things like access their contacts at the time that we need it, rather than at install time. So with Android Things, obviously, again, going back to the lack of screen, this has been stripped away because we may not have a screen, so we may not be able to grant those permissions. So all permissions are now granted at install time. So the next point is staying up to date. So because we're using the exact same OS as we find on the other Android devices in the ecosystem, we're hooked into the same updates and stuff. And I think Google ship a Android security patch monthly, maybe. So we're hooked into those same updates. We're not going to be relying on some unknown third-party vendor to ship us some update that we're waiting for that's like urgent. We're hooked into the same updates flow as other Android devices. And the final point here is distribution. I think, although development is a huge part of sort of when we're making apps and stuff, distribution is a whole other part. And I think it's often easy to take this for granted and forget just how much the Play Store is doing for us. So Play Store isn't just about discovery and discovering apps. It's also, we have beta channels, alpha channels, automatic updates. We can just drag and drop our APK and release it to the world. So with Android Things, this will be mimicked as well. So whilst the Play Store isn't going to directly support Android Things, there's planned to be what's called an IoT console, which will work in the same way. We'll be able to upload our APK into the IoT console, and Google will take care of sort of managing this and distributing it to our devices that are out in the market. Which I think that is a huge point, because it's, again, adding to that ease of us for being able to both develop Internet of Things devices and also release them. But saying this, with mobile development and web development and everything, if we make mistakes or if we need to change stuff, it's easy to do so. I'm sure there's been times when we've noticed a typo in our code, or there's a bug, or some style isn't looking quite right, or we've broken something from changing something somewhere else in our code. And it's easy. We can, although it's not a great thing, we can upload a new APK, and our users, in a matter of a couple of hours, will have access to it. And even though with this IoT console, I don't know the time frame for updates, even though this will be, similar, we'll be able to fix software issues, this isn't necessarily going to be the same for hardware. What if we miss out a core? What if we miss that stage of planning in creating our device, and we forget to put some core functionality on the device, or a couple of weeks after release, I think, oh, damn it, we should have had this button there, and this would have greatly simplified the experience. If we miss that initial stage of thinking, you don't want to have to release a new version of your product. I'm not going to pay £200 more for V2 of a product when I've just bought the old one. I think the key point here is prototyping. Prototyping a device and learning from it and testing it and playing around with it. And I think this is where Android Things makes things extremely easy because of the devices that we have access to. For example, you can buy a Raspberry Pi and you can connect a breadboard to it and play around with your heart's content. And I wanted to talk about prototyping because it's a great way of learning. And I was originally going to talk about throwaway devices like flashing lights and blinking things and pushing just buttons to turn lights on. And I think those projects are great. Make as many blinking light projects as you want because that's the way to learn. But I wanted to build something for this talk that was, maybe a little bit more prototypey, that's kind of like a product that, you could test and play around with. So I built this, and I just whacked this together. It's, because I'm so great at naming things, it's called BrailleBox. And BrailleBox is a Braille newsreader. And what it does, so it's a connected device. You push the button, it hits off to a news API. It sends me back the latest news article, and it reads it out in Braille. I don't speak Braille, but it's got unit tests, so I'm pretty sure it's working. And obviously this is a bit bigger than it would be in real life, but it's a prototype. And what it does is those pins are originally inside the box, and as it reads out the article, they pop up and down. If you're not familiar with Braille, this is what Braille is. I'm not going to go too much into it. It's essentially an influence. My mum's sight impaired, and we were looking at Braille at one. She doesn't read Braille, but she's got deteriorating sight, and we were looking at Braille at one point, and I was like, oh, I could, you could easily recreate that in some physical means. Like, refreshable Braille displays already exist, but they cost thousands of pounds. And sorry to go off on one here, but I think this is a great point to make, that Internet of Things can make things accessible for many. Like, this cost me about £60 to build. Although it would probably cost a bit more to make it smaller, but I think having access to these cheaper components, and we can create a lot more. So Braille was represented in forms of 6 points, and you can raise those points, and combinations of these raised points create letters, and then you can string these together to create words. And then you can already see here, so we've got 6 points that we need to recreate. So my thinking was like, oh hey, we need 6 physical things that can pop up and down, so that I can recreate these combinations of words. And this is what we come to. I mean, it looks a bit overwhelming at first, but we're going to break it down and just quickly run through the components that were put together to build this. So these, just to go over it quickly, these things are called solenoids, and these are what are used to pop up these pins up and down. Essentially, you give them a voltage. So these are up by default, and you give them a voltage, and they'll go in. You release that voltage, and they'll pop up. It's as simple as that. And you can probably see here that this circuit for each solenoid is exactly the same. So although I'm no electronics expert, all I had to do was get it working once and copy and paste it 6 times, and it was working. So this device on the left, we're not going to go too much into, but what this is called a Raspberry Pi, and this is where the Android Things OS sits. You can buy these for about £40. And this is essentially what holds the software, our application, that does all the work for us, such as the network requests. We're not going to go into the app itself. I just want to run through each of these components. So the first one, this is your foundations for prototyping. This is called a breadboard. And breadboards are great. First of all, they're cheap. This is about £1.99 off eBay. And second of all, it's reusable, and it's great for learning. So if you did electronics at school, you may remember having to faff around with a soldering iron, soldering your components together, realizing it didn't work, having to unsolder it and resolder it again, and making those mistakes. And it was kind of a bit demotivating. So breadboards are great because you can plug components in, and you can if things don't work, you can move things around easily and just test. And they're great for prototyping, and it's a great way of learning, because if you're not one for reading theory over and over, you can be practical and use breadboards to do it. And essentially, we're not going too much into it, because I think the best way to learn from these is to play around with them. But essentially, we have these bars at the top. This is the power bar, so you can power that. And this is the grounding bar, which you need to ground to your Raspberry Pi. And then these strips here are in vertical columns. So if I decide to power one of these columns, then that has a positive power, and I can plug components into these, and then I can chain components along and plug them into each other. So if we go back to this, you can see here that I'm passing power from my Raspberry Pi into this, and then I'm powering each rail. So here, you can see here we're chaining components on from left to right and passing the power through each one of these columns, eventually reaching the solenoid. So that's a breadboard in a nutshell. Like I said, I think the best way to learn about one of these is to grab one for yourself and play around with it. So to run through the schematics a bit more about what each part is doing. So yeah, like I said, the solenoid is done once and we copied it over 6 times. So the first part is the grounding point. So I'm not an electronics expert, and I'm not going to go too much into this, but a grounding is kind of like a security point for your circuit. And basically, electronic charge can build up, and grounding your circuit protects any components on your board from any unwanted charge that may damage your components. Cool. So the most important part of this circuit is this point here. So the point where our Raspberry Pi sends data to our breadboard. So this is the GPIO connection. So although GPIO sounds like quite a scary term, it basically stands for General Purpose Input-Output. So it's the point at where our device can communicate with our breadboard components and vice versa. So each device that you can buy that supports Android things comes with sort of a GPIO pinout, generally shaped like this, and this is what it consists of. So although at first it sounds a bit overwhelming, these labels sort of simplify and break it down a bit. So you can see here, these are the powering and ground points of our Raspberry Pi, and these are them here on this pinout diagram. And then you'll notice that all the rest of the pins are GPIO communication pins. And the thing about these is they're simply just, like I said, a way for us to output data from our board, output data from our device, and send data back to it. And a key point here is that each one of these pins has a unique identifier. So we can use this identifier in our code to reference the pins and make use of it. We're not going to go into too much code here, but I just want to brush over how simple the peripheral input-output API is to use. So that API comes with a peripheral manager service class, which is an Android service class that is used to manage any connections to and from our device. So we can use that service to essentially begin by opening the pin. And this pin can be opened using that unique GPIO pin reference. So here we just say, hey, service, open the pin. And this pin is that, I think it's like a 6-digit reference string. And as soon as we've done that, if that's successful, then we have access to work with that pin. And then in BrailleBox, we need to declare that the pin is an output pin. So because a pin can be an output or input, we need to tell our software that, hey, this GPIO pin is an output. So we can use the setDirection method to say whether it's an input or output pin, and also state whether it should start whether it's initially at low voltage or at high voltage. And because the solenoids are lower when they've got high voltage, I've set mine to initially low so that they're up by default, and then I programmatically lower them in the software. And then we need to say, let the software know that this pin is active when it's got a high voltage. There may be cases when you need it to be active at low voltage, but this allows you to state what the active state of the component is in terms of the voltage. And finally, you can also register a callback for any events that happen. So say if you're using a button, you can register a callback to that GPIO pin. So this is simply just an abstract interface that you implement of like a callback method that essentially gives you a value back to say whether that pin has been activated or not. And that is essentially all there is to those solenoids. Like those literally 4 lines of code are all that are used to tell the solenoids to pop up and down. And we can do other things with the GPIO pin. There's more methods available in the API, but those are simply the 4 ones that we used. And I just wanted to state how simple that API is to use to do what BrailleBox is doing. And then to sum up the last few parts of the breadboard and the schematics, again, not going to go too depth here. I just want these to be like plant seeds so that maybe if you go and work on a project, you might be like, hey, this guy said about resistors. So this is a resistor. So basically, a resistor allows us to reduce the flow of current in the circuit. And what we can do with a resistor is reduce the current that's flowing from that battery to the LED, which means that our LED won't burn out. Similar to like a light switch, when you dim a light, that's essentially applying more resistance to that light so that the voltage that reaches it is lower, which makes your light shine lower. And the final part is a diode. A diode is essentially allows you to restrict the direction in which current flows. So basically, because the solenoids hold a charge, even when they're released, they can still hold a charge because they're like an electromagnet. A diode essentially means that if a current's flown through to my solenoid, no current can flow back in the opposite direction. Because if that happened, then the current would flow back to my Raspberry Pi and probably damage it. So that's what's a diode for restricting the direction in which current can flow. And you've probably heard of LEDs before. An LED is essentially a diode, except it flashes. So yeah, that's pretty much the same thing, but they just light up. And then the final part of the breadboard is the circuit is just going from the diode to the solenoid. So our current's made that journey from our Raspberry Pi. It's set that value. The flow of current's been restricted. We've gone through the diode. No current can go back, and then our solenoid becomes powered, and we can read out the braille display. And in terms of the breadboard, that's essentially what I wanted to go through, just to, I didn't want to go too deep into things. And like I said, hopefully, if you do come to build things, then you've got that tiny little bit of knowledge now. You'd be like, oh, yeah, maybe I need this component, or maybe you're just slightly bit more aware of what's available. And the final point to talk about with the difference with Android Things app is, so we talked about not having a screen, is how does the app launch? So the BrailleBox doesn't have a screen. How's the app launched on the app? So in Android development, we have what's called is a manifest file. And so the difference here now is with the Things API is that we have an intent filter, which is known as the IoT launcher. And this is perfect because as soon as we declare an activity to have this category, then this activity is automatically launched when our device boots. So now we don't have a screen, but as soon as I plug in the BrailleBox and it boots up, the app is launched automatically by the system. Yeah, so if you, the BrailleBox app is open source on GitHub. If you want to have a look at it or clone it and play around with it yourself. And there's also, I did a full write-up on it about the circuit and the software up on Medium if you want to check it out there. And yeah, that's it from me. I hope there was enough information there to spark some curiosity about Android things and the Internet of Things itself. Yeah, so that's all, yeah. If you want to follow me on Twitter, stuff's there.
The question was if you have any demo to show us.
Demo? Of
I mean, I just wanted to use the microphone.
Oh, yeah. I have got a video on YouTube, but I don't know if I can get it up. Maybe if you give me a minute. Ooh. It's probably like the most unexciting demo that's ever. It's essentially just, yeah, so pretty anticlimactic looking at it. But yeah, so the pins pop up and down just to read out Braille. I can fast forward it. So that's all the solenoids look like. I had to use bits of Lego to prop them up a bit higher. But yeah, I hope that's useful at all, just to see. And then if you want to see the circuit, then there's a bit more there. This is going to be up on, Google have a site called Android Experiments, and I think this is going to be up on there next month, so there's be a few more videos there if you want to check that out then. Cool. Brilliant, thank you.